Hello everyone, how is it going? I hope you all are doing well. Let us begin today's session. We all know that wood has been used as a fuel for a long time. We have also studied other conventional sources of energy. When wood is burnt in a limited supply of oxygen, water and volatile materials present in it get removed and charcoal is left behind as the residue. Now, here, volatile material is used. What is the meaning of volatile material? The materials which can be easily evaporated. So, when wood is burnt in a limited supply of oxygen, what happens? Water and other materials which can be easily evaporated, which are present in it, will be removed, and only the charcoal will be left behind as residue. Charcoal burns without flames and it is comparatively smokeless and it has higher heat generation efficiency. It can generate more heat. We have learned about fossil fuels also. Now, as the population of the country increases, we need to find some improvements in the technology. So, what can be the improvements for conventional sources of energy? Let us learn now improvements in the technology for using conventional sources of energy. So, now we will learn about biomass energy. When cow dung, various plant materials like the residue after harvesting the crops, vegetable waste, and sewage, when they are decomposed in the absence of oxygen to give biogas. Since the starting material is mainly cow dung, please remember the main thing is cow dung. It is popularly known as gobar gas, which we all know. Biogas is produced in a plant. So, first of all, you need to remember what is a biomass. What it is? When cow dung, it is the main component, and other materials, plant waste as well as animal waste, when they are decomposed in the absence of oxygen. We all know what is decomposition, right? It is the breakdown of substances. So when these are decomposed, how? In the absence of oxygen, then the biomass is produced. And where it is produced? Biogas is produced in a plant. So this is a schematic diagram of a biogas plant. Let us see what it is. The plant has a dome-like structure built with bricks. Now you see in the figure where gas tank is written, on the upper side of gas tank where it is written, you can see inverted dome-like shape, dome-like structure, which is made up of bricks. A slurry. Now you see mixing tank on the left hand side. That is a mixing tank where the mixture is taken place. Now there are gas tank, there will be gas outlet, digester, there will be mixing tank. So first will be the function of mixing tank where slurry is present. Now what is slurry? Slurry is a mixture of cow dung and water. Okay, remember this. Slurry of cow dung and water. Where it is made? It is made in the mixing tank. Now once the slurry is made, it is sent to the digester. Now you see in the figure, where is digester? It is the main part. What is this a digester? This digester is a chamber which is sealed. How it is sealed? So that there is no presence of oxygen. In this sealed chamber, it is constructed in such a way that there can be no oxygen present in it. So there will be anaerobic microorganisms. Now we all know what are microorganisms. Anaerobic. We have learned a similar kind of words in chapter number 6, right? Anaerobic respiration means when there is absence of oxygen. Here, anaerobic microorganisms, which means the microorganisms which do not require oxygen. Okay, so in this digester, anaerobic microorganisms will be there which do not need oxygen, will decompose of this cow dung slurry. What will happen? Decomposition of cow dung slurry. Decomposition means what? Breakdown of complex substances into simpler substances. Okay, it will take few days for the decomposition process to be complete, and it will generate gases like methane, carbon dioxide, hydrogen, and hydrogen sulfide. The biogas is stored in the gas tank. You see, gas tank is there above the digester. So this biogases will be stored in the gas tank, and when they are needed, they can be drawn through the pipe, which is gas outlet. Okay, so this way the plant works. Let us revise it once again. There is a mixing tank where the mixture of cow dung and water will take place. From that, the slurry, which is a mixture of cow dung and water, will be sent to the digester. What will be this digester is? This digester is a sealed chamber where there is no oxygen. In this digester, the anaerobic microorganism will decompose this slurry and produces methane, carbon dioxide, hydrogen, hydrogen sulfide. Okay, these are biogas. When they are prepared, it will be stored in the gas tank, and whenever it is needed, it will be taken out from the gas outlet. So this is the working of biogas plant. Let us see some of the advantages. Biogas is an excellent fuel as it contains up to 75% of methane. This is the most important. It contains 75% of methane. That is why it is called an excellent fuel. Another advantage, it burns without smoke. Also, it leaves no residue like ash in wood, charcoal, and coal burning. So, when we burn wood, it leaves residue of ashes, right? Here, it will leave no residue. There is no residue after it burns. Its heating capacity is high. Biogas is also used for lighting. The slurry left behind is removed periodically and used as an excellent manure which is rich in nitrogen and phosphorus. When this slurry is made and microorganisms prepare biogas, at that time some of the slurry will be left in the mixing tank, so which is left behind can be taken out and used as manure. We all know manures are very much important, and this manure will be rich in nitrogen and phosphorus. The large-scale utilization of bio-waste and sewage material will provide a safe and efficient method of waste disposal besides supplying energy and manure. In this way, biogas is good fuel. So this is all about biomass energy.